Download this code from codegive.com, link in the description below. Gradient regularization tutorial. Gradient regularization is a technique used in machine learning to prevent overfitting by adding a penalty to the loss function based on the gradients of the model parameters. It works by constraining the model's weight updates during training, encouraging smoother and more stable convergence. The concept is based on the idea that large gradients can lead to large updates in the weights, which may cause the model to oscillate or overfit to the training data. By applying a regularization term based on the gradients, we can stabilize the training process. Common gradient regularization techniques. 1. Gradient clipping limits the magnitude of gradients during training. 2. Gradient noise adds noise to the gradients to encourage exploration. 3. Weight decay, a form of L2 regularization that can be adapted to gradients. Implementation example, gradient clipping. Here, we will implement gradient clipping using PyTorch. This is a common method used with neural networks to prevent exploding gradients. Setting up the environment. Make sure you have PyTorch installed. You can install it using pip. Code example. Explanation of the code. 1. Model definition. We define a simple neural network simplen with 2 fully connected layers. 2. Data preparation. We load the NIST dataset and apply normalization. 3. Loss and optimizer. We use cross-entropy loss for classification tasks and atom optimizer with a learning rate of 0.001. 4. Training loop. We iterate through the dataset for a specified number of epochs. For each batch, we perform a forward pass to compute the outputs and the loss. We call loss.backward to compute the gradients. We apply gradient clipping using torch.nn.utils.clip_grad_norm_, which ensures that the gradients do not exceed the specified threshold, clip_value. Finally, we update the model weights with optimizer.step. Conclusion. Gradient regularization, particularly through gradient clipping, is a powerful technique to stabilize training and improve the generalization of machine learning models. This approach is especially useful in deep learning where gradients can become very large. By implementing gradient clipping, you help ensure that your model converges more smoothly. Feel free to experiment with different architectures, data sets, and clipping values to see how it affects the training process.